gravity system, okay, is often seen as the first choice alternative in a centralized model. It would be very costly, we found, to retrofit the existing zones 3 and 4. Original design of these communities, such as Southcott, were a decentralized system for individual treatments. With government funding, a shallow depth approach, and phasing of infrastructure under the roadways as they need to be replaced would make a centralized, this model for the centralized system more viable. Next slide. What I'm presenting here is some numbers that were presented to the community by Dillon and Associates on October 29th, 2009 in a public information center. We've extrapolated some of these figures and adding the number of homes, as you see down the second column there, for zone 3 and 4, and 2 columns to the far right, which would be an extension of using the home numbers, dividing the low pressure total cost, or the low pressure cost for each area, and coming up with a per household estimate. Okay? Please understand, to date, we have not received any accurate per household costing for zone 3s and 4. This gives you some idea. Next slide, please. Elizabeth will go into the costing model a little bit more detail, but I'd like to touch upon a couple of aspects. One of the things we found with looking at the different models throughout the community is that each property is going to have its own set of circumstances. Not only will the zone itself. We have found, however, that in the costing between grinders and the gravity system, there has been some work done in this area where they are comparable numbers if the road surface is replaced at the same time. So I refer back to when we had made a recommendation that this be looked at when road surfaces are going to be replaced. User rates for domestic water and sewage rates will affect everybody across the board. And it will be an ongoing cost to anybody on a centralized system. For decentralized system, okay, or on-site system, that's not a factor. There's 2 costs associated with the centralized system. The lot cost, which brings the piping to the lot, and then the actual site cost, which takes the piping connection, okay, into your home. So the lot cost is something that would be levied by the municipality. The site cost would be something that the homeowner would have to assume, because each lot would have a varied range of issues, whether it be your landscaping, your driveway, connections, the location of your discharge out of your home. Each one would have a unique circumstance. We've seen some pricing and some modeling of this by Dillon in other areas of municipalities. And in closing, what I'd like to say is that we have done some estimating of costings for tertiary systems, which are now being managed by the county as far as under the building code for installations. And the cost ranges from $10,000 to $20,000, depending, once again, on site demands and conditions. Next slide. found is that this discussion, okay, between the two models, centralized and decentralized, has unfortunately become an all or nothing debate. And one of the things we found is that because of the demographics, where there's a high demand, okay, in particular areas of our community, and a very low demand over the season in other areas, there's room for both models. We find it cost effective, we find it beneficial, okay, and we find it environmentally sensitive. This is the two, the centralized and decentralized models. The other thing we find is, one of the primary reasons we've seen this desire for an upgrade of the existing SDF is for capacity. And we believe, we support the development in this area, but we believe that the most cost-effective way to construct a centralized system, okay, with a collection system is through new development. And the other issue with the development is setting of timelines upon that development so that we know what to expect for cost recovery as far as the capital expenditure on the plant is concerned. And in closing, management of a decentralized system is pretty well key. We found from the Arkell Center their recommendations throughout the province is education and enforcement. And we would like to see that type of model. We believe it's a cost-effective approach, and for a future association with the Arkell Center would be a very welcome thing. Thank you.
I'm back again, being team leader for the topic of future options. I'm going to cover a little bit what Ernie discussed because it melds in, but I'm going to discuss it in a different vein. And basically I'm going to look at the off-site options that he talked about, the centralized system, and the on-site options, essentially the septic tanks. Starting with Plan A, which is the off-site treatment options. This requires two components, very expensive components, and one is a sewer pipe collection system, and secondly, the capacity at a central sanitary treatment facility. What are the options for a sewer collection system? And those Ernie touched on. First one is what I call Plan A1, a gravity sewer collection system. Talking with various engineers in other municipalities, this is the gold standard for sewage collection. You always plan for a gravity system, and primarily because it is a very simple system, requires no hydro, everything moves downhill, simple, flush it and forget it. The municipality will take care of the rest. Some of the advantages, well, the red didn't show up very here, the light, but anyways, the upper one is the advantages to a gravity system. It is the lowest operating and has the lowest maintenance cost. The only big draw on this is you have to construct lift stations, but generally these lift stations are very robust, efficient, and quite reliable. Disadvantages to a gravity system is its high capital cost. It involves trenching the roads and putting in these lines that have to, of course, flow downhill. It's quite invasive.